Welcome to the geometry week of April 5th recording. And I want you guys to make sure that you have your math notebook out so that you can take good notes. That will help you when you go to do this week's assignments. And for our warm up this week, I'm gonna have you guys look at what your current grade is. So go ahead and open your geometry course in another window and just look at what your current grade is in the course. And then I want you to think about what you want your grade to be for the end of the school year, for your second semester grade. And are you close to that grade? We are about 7 weeks out from the end of the school year, so I want you guys to start thinking about what is your goal grade to end this course in, and how can you get to that grade. And one way of doing that is redoing any low scoring assignments and turning in any missing assignments. So go ahead and look through your current grades and see if you have any missing assignments. And if you do have any missing assignments, make sure you get those submitted as soon as possible. And then just a friendly reminder that you do need to let me know with an email when you've turned any missing assignments in. So let me know when you submit missing assignments. Remember, Schoology unfortunately does not alert me when you submit your missing work, so you need to be proactive and let me know when you've submitted work so that I know to grade it. Okay. So this week we are going to have a lighter week of assignments, a lighter week just because we are in the middle. I know you guys are taking your state standardized test, your CMAS and PARCC for the next couple of weeks. So I am going to scale down your assignments. Usually we have about 3 assignments due, so we're only going to do 2 this week. We're starting Unit 8 on circles, so we're going to cover Session 1 and 2 this week. All right, so let's jump right in and try and make this recording as short as sweet as possible. And let's talk about some of the vocab words you're going to see this weekend throughout Unit 8 regarding and relating to circles. So the first word is chord, And a chord of a circle is where we have the endpoints of a segment lying on the circle. So that would be an example of a chord. So a chord is a segment whose endpoints lie on the circle. It does not have to go through the center of the circle to be a chord. It only needs to go from one endpoint of the circle to the other. And a secant, let's talk about a secant next. We'll do that in another color so that we can visually see. We'll do that in purple. So a secant is a line. So before a chord was a segment, wherein a secant is a line. Remember, a line can continue on in both directions infinitely. A line that intersects a circle at 2 points. And we're going to draw an example here. So remember, it's a line, so it's going to continue on in both directions, and it's going to intersect the circle at 2 points. So let's do an example of a secant. So it's a line, so I do need to add on my 2 arrows to show that it is a secant. It's a line. So that's a secant, where these up above were our chords. Then we've got a tangent, and a tangent is a line, like a secant, they're both lines, but a tangent is a line that only intersects intersects the circle at one point. It's a line that intersects a circle at one point. At only one point, where a secant intersected at 2 points. Tangent intersects only at 1 point. So an example would be, oops, I wanted that to be a line. So I'm going to use the line feature to draw that. And it's only going to intersect at 1 point. So there we've got an example of a tangent. And I'm going to add on my little arrows to show that it is a line. And then the point of tangency is where that tangent line intersects. So it's where the tangent line intersects the circle. So I'm going to go ahead and highlight that, and we'll highlight that in yellow. Point of tangency. So since there's our tangent line right here, here's our tangent line, and it intersects our circle right there, so that would be the point of tangency. So the only segment we have here is a chord. A chord is the only segment that we have out of all these vocab words. The rest are all lines. Secant, the line is going to intersect the circle in 2 places, where tangent and only intersects in 1 point. All right. So moving on, I'm going to go to the next slide. So if you do need more time, go ahead and click pause now to take notes. Let's use some properties of tangents. So tangents, remember, is a line that only intersects our circle in 1 place. So if we have 2 segments now, we're talking about segments that are tangent. So here they only touch the circle in 1 place, right here and here. So this is a tangent segment, and this is a tangent segment. So if you have 2 segments that are tangent, 2 segments that are tangent from the same external point, so they're both starting from this point, then the segments are going to be congruent. So here, we started, both of our tangent segments started from this point, this same shared point. So that tells us, according to this property that we're now learning, these segments are going to be congruent. These segments are going to be congruent. So I just need to add, so we'll call this point D, we'll call this point E, we'll call this point F, and we want to, this is circle C. So the question says, if DE, segment DE and DF are tangent to the circle, we want to find the length of DF. We want to find the length of DF. So we know, because these 2 segments are tangent segments that start from the same point, they're congruent. So what we can do is set those 2 segment lengths congruent to each other. So we can say that DE is equal to DF. And then let's substitute in the given information. DE was, the length is n plus 3, and DF is D2n minus 1. So we can solve for the variable n. We've got enough information. I'm going to move this up because we're going to run out of space here. Ooh, for solving that. So we just need to solve for n. We need to get all the n variables on one side of the equation and all the constant terms on the other. So I'm going to move this n. I'm going to subtract it from both sides. And that gives us 3 equals 2n minus 1n is just n minus 1. Then we're going to add 1 to both sides, and that's going to give our value of n. N equals 4. So we found our value of n, but we were asked to find df. So df is represented by 2n minus 1. Well, now we know that n equals 4. So when we see n, we're going to substitute in 4 and solve for df, the length of df. 2 times 4 is 8. 8 minus 1 is 7. So the length of df would be 7. So always make sure that you are answering what the question asked. Don't just solve for the variable if it asks you to then find the length of a line segment where you would actually have to plug that value into the equation that represents that segment length. Okay, so I'm going to go on to the next slide now. If you need more time, go ahead and click pause. So let's talk about arcs in our circles now. Let's talk about arcs. And by the way, everything that we just went over, tangents and chords and secants and all that, that's all from Unit 8, Session 1. Now we're looking into the vocab that you're going to see in Unit 8, Session 2. So arcs. So a arc is just part of the outside of a circle. So if you were to walk along the outside of a circle, that's an arc. Ooh, I'm having a hard time getting that highlighted. That's an example of an arc, is along the outside of your circle. Sorry about that. I've got a little bit of a cold going here. So I'm doing my best to get through this recording. So a minor arc, so an arc is just along the outside of a circle between two endpoints. You do have endpoints when we talk about arcs. There's endpoints on it. So a minor arc, let's talk about a minor arc. A minor arc is an arc whose endpoints, a minor arc is an arc whose points are on or in the interior of a central angle. So let's see here. I'm going to draw in just explain this a little bit better. I'm going to kind of talk about both the minor and major arcs kind of at the same time. So we've got this circle here, and the center of our circle, we'll call that point, how about point, we'll call that point A. The center of our circle is point A. So we have two rays. Two rays coming out of, originating from the center of our circle and passing through the circle to create an angle. So remember, two rays create an angle. So we've got this angle here. We'll call this side, this point B, and this point C. So we've got angle ABC or BAC or CAB. We've got an angle in our circle, CAB or BAC. And where that angle intersects our circle, it's intersecting the outside of our circle in two different arcs. So remember, an arc is an unbroken part of a circle along the outside of our circle. So a minor arc is going to be, when we're talking about this part here that's labeled in yellow, the minor arc is an arc whose points are on the interior of the central angle. So it's on the interior. So any of the points are on the interior. So here we could talk about the points on our circle, call them M and O. So the minor arc has points on the interior, like M, N, and O. So when you've got points on the interior of the central angle, that's your minor arc. That's your minor arc. So I'm going to put points on or in the interior of the angle. So again, we've got angle BAC, and interior to that angle are points M, N, and O, which makes arc CB a minor arc. So we would label this arc, we would say this is arc, we put a little arc above it, and then we would call that arc CB. We would call that arc CB. And then the major arc is going to be, I'm going to highlight the major arc. Let's do that in the light blue colored. Call that this one. It's going to be the bigger of the two. Major is so a major arc is an arc whose points that's an O, whose points are on or in the exterior of the angle. So all these points on this side are on the exterior side of angle BAC. So here I just added some points, this point, this point, this point, this point. And all those points in blue are on the exterior of angle BAC. So that makes this arc that's highlighted in light blue, that makes it the major arc. And I'm going to go ahead and label, how about I'm going to put angle F over here. I'm just going to label one of our points. And to find, or name our major arc, we need to put 3 points so that we know it's the major arc. So we would say CFB is, not D, CFB is the name of that major arc that's in blue. So many times you're going to want to use 3 letters to label or name your angles, your minor and so that you can tell the difference between which one is the major arc and which one is the minor arc. All right, so I'm going to move on to the next slide, and so if you need more time, go ahead and click pause. All right, so let's make sure we have these ideas down about naming minor arcs and major arcs. So what would you name the minor arc here? So I've got an angle drawn in. Oops, I'm missing we'll call this O, point O. So what would we call we've got angle AOC that is in this circle. What would we call the minor arc? What would we name the minor arc here? Which one is the minor arc? So the minor arc is going to be A, B, C. So you want the points to be on the interior of the angle in order for it to be the minor arc. So we'll highlight that in, how about yellow? The minor arc would be in yellow. And what about the major arc? It's going to be arc A, D, C. It's going to include the points on the exterior of our angle. The points that are on the exterior would be point D, so that minor arc would be AC, ADC. So I do also have an angle in here. I labeled this angle AOC. It has an angle measurement of 150 degrees. So what is true of angle measurements and arcs is that the measurement of the minor arc is going to be equal to the measurement of the central angle. So since angle AOC has a measurement of 150 degrees, that means that arc ABC is also going to be equal to 150 degrees. So the measurement of the central angle will be the same measurement of the minor arc. Now, what about the measurement of our major arc? Do you know how many degrees would be in the measurement of our major arc? So think about what we know about circles. How many total degrees are there in a circle? I'm going to move this O. Oops, that's not going to work. There's 360 degrees in a circle. There's a total of 360 degrees. So if 150 degrees are being taken up by that angle ABOC, then if we take 360 and subtract 150, that's going to give us the measurement of the angle, the exterior of angle AOC, which would also mean that the arc of ADC is going to be 210 degrees. So keep in mind that a circle has a total of 360 degrees total. That'll help you with finding a lot of the measurements. And then remember, half of a circle or a semicircle is going to have a total of 180 degrees total. It's going to have 180 degrees total. So you'll be asked to ask questions, answer questions, figuring out the length of the major arcs and the minor arcs. And just remember that you can use what you've learned about the total number of degrees in a circle, and that a semicircle is going to have 180 degrees. So let's talk about some chord theorems, and then we're going to stop there. Some chord theorems. In a circle, if a radius or diameter, so remember radius is from the center of the circle straight out and touches the outside of a circle. I'm going to do an actual straight line there. I'm going to use this thing here. Center out is a radius. So if in a circle, if the radius is perpendicular to a chord, so now I'm going to draw on a chord, and remember a chord is just a segment that intersects both sides of the circle. So if we've got a chord, I'm drawing in purple, and if it is perpendicular to the radius, then it bisects the chord and its arc. It bisects the chord and its arc. So let's put some labels, some points in here, and say that that's point C, this is point E, this is point F, and this is point D. So according to this theorem, we've got our chord in purple. Here's our chord, and it intersected the radius at 90 degrees. So we got a 90-degree angle here. Then, according to this theorem, we know that it bisects its chord. So we know that, I'm missing a point. This segment here is going to be congruent to this segment here. So here to here will be congruent from here to here. I can label that and write that out. Let's call this point EFG. We'll call that G. So we know that EG would be congruent to GF. It tells us then that the chord and the arc is going to be congruent. So we would know that arc ED is going to be congruent to arc DF. So you're going to also use that idea to solve problems in the assignments from Unit 8, Session 2. So remember this theorem because it will help you set up equations and solve for them. And that's it. I'm going to stop there. So let me think about, let me write down the key phrase assignment for you. For your key phrase assignment, you need to tell me, how are secant lines different from tangent lines? So how are secant lines and tangent lines different? And that's it. Please remember to let me know if you have questions as you're working on your assignments this week. I am here to help. And remember that we are done with Unit 7, so I'm no longer taking redos from Unit 7. I'm no longer accepting redos from Unit 7 since we've moved on to Unit 8. All right, have a wonderful rest of your week, and again, let me know if you have any questions or need any help with anything this week.